Now that you've learned what logarithms are, we are going to talk about some of their properties. And some of those you actually kind of sort of know already, and some of them we will discover new. So right now we're actually starting with two that you kind of sort of know already or have come across already probably, but we're going to clarify them and talk about why, and then we will continue to other ones that you have not met yet. So the first property, we're going to look at the first row, the logarithms in the first row, and we can remind ourselves what is a logarithm. So the logarithm always has a base. Now we take that base and we ask ourselves, what exponent do we need in order to make the number in the parentheses? So 1. So what exponent do we need up there to make a 1? Well, that would be 0. So logarithm to the base 5 of 1 equals 0. Now, for some of you, that might already answer the next three questions, but some of you might like, oh, well, how does it change when I have a different base? Let's think about that. So again, we want to think about our base is 2. Now, what exponent do we need in order to make that 2 a 1? Oh, again, it will be actually 0. So again, we have 0, and therefore our logarithm is 0 because it is the exponent that makes the number in the parentheses applied to the base. So now the next two I have in here just to kind of refresh our knowledge of when I just have log and no base written, what does that mean? And so I hope at this point you remember that that means we have base 10. So we have 10, and again the question, to what power do we have to raise our 10 in order to get a 1? Again, it will be 0. So again, our answer to log of 1 is 0. And then the last but not least, ln. What is the base there? The base is e. So we are asking ourselves, e to the what power equals 1? And again, our answer is 0. So that is the first rule or property of logarithms that we now have kind of clarified, is that no matter what the base, we had 4 different bases, if we take the logarithm of 1 to whatever base we have, we get 0. So that is here our first property. Now let's go on to the next line, the next row, and see what we find here. So now we again taking our base 5, and we want to ask ourselves, to what power do we have to raise our 5 in order to get 5? So the same number. Well, you know that already. We're just kind of rephrasing everything because it's the first power. So 5 to the power of 1 equals 5, and therefore our logarithm is 1, right? Because the logarithm is the exponent to the base that creates the number in the parentheses. So we do the same thing. Let's check if that works the same way with a different base. Our base 2 now, and we would like to keep that 2. Again, yes, that works, being 1. So that equals 1 again. And just for good measure, to check for our log, when we just have log 10, it means that since no base is written, that our base is 10, we again want this now to be the exact same number, and that always means the exponent is 1. And last but not least, our base e for the ln is, again we want e as an answer. So again our exponent is 1, and therefore ln e is 1. So that refers down here to the second rule, that logarithm to the base a of a equals 1. So if the base and the number in the parentheses, they both are the same, then our answer is 1. And it all comes back to the exponential function, to our exponents, and our logarithm being the inverse of those is just gives us exactly the same answers that we know already from our exponential explorations.